Now let's discuss about molecular docking simulation. Finding a new drug for a disease is a long, costly journey that makes a tremendous effort to obtain it. It is estimated that 7 to 12 years and $1.2 billion are needed to bring a drug into a market. Furthermore, 5 out of 40,000 compounds tested in animals reach human testing, and only 1 of 5 compounds reach clinical studies is approved. Hence, the development of computer-aided design is being widely utilized to significantly reduce the cost and time needed to find a promising candidate. Computer-aided design, or we call that one as CADD, is a technique which uses software for predicting the structural value of properties of noun, unknown, stable, and unstable molecular species using mathematical equation. Computer-aided design helps scientists in minimizing the synthetic and biological testing effort by focusing only on the most promising compound. This method has helped to expedite the drug discovery and development process by minimizing the cost and time. Computer design is usually used for three major purposes. The first one is filter compound library into a smaller set of predictive active compound that can be tested experimentally. Second, utilizing to identify hit compound or active candidate. And the last, optimizing the lead compound, for example, transform biologically active compound into a suitable drug by improving their physicochemical, pharmaceutical, ADMET, and or pharmacokinetic properties. Several combination method in computer-aided design is presented in the diagram. Let's see this slide. Structure-based design. This one. If we know the structure of protein and the ligand, a structure-based design or direct design rely on knowledge of the three-dimensional structure of the biological target obtained through methods such as X-ray crystallography or NMR spectroscopy. And de novo design, if we only know the protein structure. Molecular de novo design, which involve experimental construction of a ligand model within a model of the receptor or enzyme active site, produce novel molecular structure with desired pharmacological property from a scat. And ligand-based design, or we call this one as a LBDD, if we only know the ligand. Ligand-based drug design is an approach used in the absence of the receptor three-dimensional information, and it relies on the knowledge of molecules that bind to the biological target of interest. Molecular docking is a computational method to find the best matching between two molecules. Molecular docking, also defined as a method which predict the preferred orientation of one ligand when bound in an active site to form a stable complex. Computational docking, or we call that one as a in silico molecular docking, is a computational science aiming at predicting the optimal binding orientation and conformation of interesting molecule in space, and to estimate the stability of their complex. So let's see this one. The slide. This is a target, and this is a ligand, and this one are complex. See this one also. Then we have this complex. There are several components of docking, such as receptor, the receiving molecule, most commonly a protein or other biopolymer. Ligand, the complementary partner molecule which bind to the receptor. Binding site or active site, the part of receptor where the ligand bind. Pose or binding mode. In this case, the geometry of the ligand in the binding site. And then a scoring method. A method to calculate a score binding affinity for a particular pose. And the last is a ranking. This one is the process of classifying which ligands are most likely to interact favorably to a particular receptor based on the predicted free energy binding. Then let's move to molecular docking model. There are several molecular docking models, such as the lock and key theory. In this case, we call that one as a rigid docking. A substrate fit into the active site of macromolecule. The first step of the rigid docking method involves the construction of a negative image of the binding site of a series of overlapping sphere of parent derived from the molecular surface of the protein. The ligand conformation is then oriented into the binding site. After checking to ensure that there are no unacceptable steric interaction, it is then scored. New orientation are produced by generating new set of matching ligand atom and sphere as center. The procedure continue until all possible match have been considered. Then the fit, the induced fit theory, or we call that one as a flexible docking. Both ligand and target macromolecule mutually adapt to each other through a small conformational change until optimal fit is achieved. Conformation of each molecule are generated on the fly by search algorithm during the docking process. The algorithm can avoid considering conformation that do not fit. And the last is the conformation assemble model. Discuss a recent model describe protein as a pre-existing assemble of conformational state. Now let's move to type of docking. There are two types of molecular docking. The first one is protein ligand docking. Protein ligand docking is a molecular modeling technique which aims to predict the position and orientation of a ligand. A small molecule, in this case, when it is bound to a protein receptor or enzyme. See this picture in this slide. This target ligand, and this is a molecular docking. Then the second one is a protein docking. Protein docking is the computational modeling of the quaternary structure of complex formed by two or more interacting biological macromolecules. Docking itself only produces plausible candidate structure. This candidate must be ranked using methods such as scoring function to identify structures that are most likely to occur in nature. So let's see the picture one more time. This is target, ligand, then we have in hand molecular docking. Then see this one. Several software which use for molecular docking simulation can be seen in this slide. Molecular operating environment. This is commercial available. Autodoc, Gemdoc, Gram, and Gold. Now let's move to a practical aspect. In molecular docking, firstly, we need a receptor or protein target. Receptor or protein is obtained from database such as protein data bank, or we call this one as a PDB. PDB is structure often contain water molecule. In general, all water molecules are removed except where it is known that they play an important role in coordinating the ligand. A PDB structure also often missing or hydrogen atom because the capacity of the protein structure determination method. Many docking programs require the protein to have explicit hydrogen. Now let's see this one. The Ligand Database. The Ligand Database is a composite dataset comprising 3 sections: compound, reaction, and enzyme. See this one. The Ligand Database is a composite database comprising a three-section compound for the information about metabolite and other chemical compound, reaction for collection of substrate product relationship representing metabolic and other reaction, an enzyme for the information about enzyme molecule. Several databases of ligand such as PubChem, ChemBL, and Zinc5 pose in molecular docking defined as a candidate of binding mode. Searching a pose is an essential part in molecular docking process. The difficulty of searching a pose is due to many of degree of freedom. The fact the involve of degree of freedom such as first, the translational and rotation of one molecule relative to another involved in 6 degrees of freedom. There are, in addition, the conformational degree of freedom of both the ligand and protein. Also, another factor that involved on a searching of pose is search of algorithm. Search algorithm for a general pose and orientation of conformation of the molecule in the binding site aim to tries to cover desert space, if not exhaustively, then as extensively as possible. Then there is a trade-off between time and set space coverage. So let's see this one, ligand conformation. Conformation can be defined as the shape adapted by a molecule caused by the rotation around the one or more single bond, and a conformation of the ligand may be generated in absence of the receptor and subsequent docking. Another aspect of technical in molecular docking is a ligand conformation. As I have already told you before, that this one conformation can be defined as the shape adopted by a molecule caused by the rotation around one or more single bond. Conformation of the ligand may be generated in the absence of the receptor and subsequently dock, or conformation may be generated on the fly in the presence of the receptor binding cavity or with full rotational flexibility of every dihedral angle using fragment-based docking. And additive function that include presentation of various interaction between a ligand, this one in a small molecule, and a target. This representation describe the electrostatic, hydrophobic, solvation, and hydrogen bonding interaction between the two molecules. Scoring a function aimed to calculating the quality of docking complex and guiding the docking algorithm. The bonding process that lead to the formation of a complex between a ligand and its receptor is controlled by several factors, including the interaction energy between the two molecules, the dissolution and solvation energy associated with the interacting molecule, and the entropy factor that occur upon binding. Now let's move to docking assessment. An assessment of a docking protocol is generally required to determine its predictive capability. Docking assessment can be performed using different strategies such as docking accuracy calculation represent one measure to quantify the fitness of a docking program by rationalizing the ability to predict the right pose of a ligand with respect to the experimentally observed. Then the correlation between a docking score and the experimental response or determination of the enrichment factor. Docking screen can also be evaluated by the enrichment of annotation ligand of non-binder from among a database of presumed non-binding decoy molecule. In this way, the success of docking screen is evaluated by its capacity to enrich the small number of non-active compounds in the top rank of a screen from among a much greater number of decoy molecules in the database. Then the distance between an ion binding moiety and the ion in the active site. The last is the presence of inductive model. I think that's all for our discussion for this moment. Thank you for your attention.